You have to consider the diagonals is nothing but the given A vector is D1 vector and given B vector is D2 vector. If they ask the triangle, then half into magnitude of A vector cross B vector. When they have given the diagonals, you have to take half magnitude of D1 vector cross D2 vector. When they have given adjacent sides, you have to take it only the magnitude of A vector cross B vector. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learnt many problems on area of a triangle, isn't it? And in today's session, dear students, here we are having session number 7, chapter number 10 called Vector Algebra. And in this session, we are going to learn a 3-marker problems of a area of a parallelogram. Okay, and then some other types of problems we are going to learn it here. Now we'll be moving on to the problem number 1. They've asked like this: find the area of the parallelogram whose adjacent sides are given by vector A is equals to I minus 2j plus 3k and vector B is equals to 2i minus 7j plus k. So here you know that area of, they have asked here parallelogram. Area of parallelogram is given by, let me write the formula first, magnitude of A vector cross B vector. Okay. So, but area of a triangle is given by half into magnitude of A vector cross B vector. Let us find out first A vector cross B vector and then we'll find out the magnitude. First you have to take in the first row as ijk and then next row you have to do with the coefficient of A vector 1, minus 2 and 3. 1, minus 2 and then 3. And coefficient of B vector 2, minus 7 and j, which is 2, minus 7 and k is nothing but 1. So let us expand this by having I cap into, so you have to leave first column, first row, minus 2 into 1, minus of 7, minus 7 into 3. So minus 2 into 1 is minus 2, minus of minus plus, 7 3s are 21. Again minus j cap into, you are getting, leaving the second column and the first row, 1 into 1 is 1, minus 2 into 3 is nothing but 6. Similarly, plus k into, you have to leave the third column and the first row. 1 into minus 7 is minus 7. Already 1 minus sign is there. Minus of minus, it will become plus. 2 2s are 4. I hope you understood this. Now, let us simplify this. Minus 2 plus 21 is giving you 19. So, 19 I cap. 1 minus 6 is minus 5. Minus 5 into minus is nothing but plus 5 j cap. Here, minus 7 plus 4 gives you minus 3. Minus 3 into plus is nothing but minus 3k cap. Okay. So, this is your A cross, what is that? A vector cross B vector. Now, you need to find out the magnitude. So, magnitude of A vector cross B vector is nothing but under the root of coefficient of I is nothing but 19 squared plus coefficient of j is 5 square and coefficient of k is minus 3 whole square. Let us simplify this one, you will be getting the answer. So you know that 19 squared is nothing but 361. So 361 plus 5 squared is 25 plus 3 squared is nothing but 9. Let us simplify this. 361 plus 25 plus 9 gives you 395 under the root of 395. So the answer will be is equals to magnitude of that one, which is under the root of 395 square units. That's it, dears. Okay. So this is how you are going to simplify the answer. I hope you got this one. Now, we'll be moving on to the next problem. What they've asked, find the area of the parallelogram with A vector is equals to 3i plus j plus 4k and B vector is equals to I minus j plus k as adjacent sides. So, here they have given already the adjacent sides. Same like the before, we are going to take it as, first let us do A vector cross B vector, writing the row as ijk. So, writing the row as ijk and coefficients of A vector, which is 3, 1 and then 4. B vector, I coefficient is 1, j coefficient is minus 1, k coefficient is 1. Expanding this, you are going to get I cap into leaving the first column, first row, 1 into 1 is 1, already minus symbol is there, another minus will be here, plus it will become 1 into 4 is 4. Again minus j cap into leaving the second column, first row, 3 into 1 is 3, 1 into 4 is minus 4 because you have to get it with the minus sign for the second term, right? So next plus k cap into you leaving the third column, first row, 3 into minus 1 is minus 3, minus 1 into 1 is 1. Now let us further simplify this one. 1 plus 4 is 5i cap. Again 3 minus 4 gives you minus 1. Minus into minus it will become plus j cap. Again minus 3 minus 1 is minus 4. Minus 4 into plus is nothing but minus 4k cap. Now this is what you got, A vector cross B vector. Now you need to find out the magnitude of A vector cross B vector, which is going to be known as the area of a parallelogram. So which will be is equals to, you can take under the root of 5 squared plus coefficient of j is 1 squared. Again coefficient of k is minus 4 squared plus minus 4 whole squared. Let us simplify further. Under the root 25 plus 1 plus 16. So it will be giving you the answer as 25 plus 16, 41 plus 1 is root 42. So this is what called area of a parallelogram, square units. That's it. Okay. So this is your final answer. I hope you understood this one also. Now we'll be moving on to the next problem. Find the area of the parallelogram whose diagonals, they have given here diagonals, are A vector is equals to 2i plus j plus 4k and B vector is equals to I minus 2j plus 2k. You have to consider the diagonals is nothing but the given A vector is d1 vector and given B vector is d2 vector. So here area of a parallelogram whose diagonals are given, area of parallelogram whose diagonals are given, is given by the formula half into magnitude of A vector cross B vector. Actually it is d1 vector cross d2 vector. Since they have named already A and B, I am taking like this only. Okay, I am taking like that only. Now let me find out first what is A vector cross B vector. So which is given by I, j and then k. So you are writing the coefficient of A vector, which is 2, 1 and then 4. Coefficient of B vector 1, minus 2 and 2. Now expanding this, you are going to get it as, which implies that I into leaving the first column, first row, I cap. 1 into 2 is 2. Already minus symbol is there. It will become here plus. 4 into 2 is 8. Minus j cap into leaving the second column and the first row, 2 into 2 is 4 minus 1 into 4 is 4. So again plus k into leaving the third column and the first row, 2 into minus 2 is minus 4 minus 1 into 1 is nothing but 1. Now further simplify this. 8 plus 2 is 10 I cap. Again 4 minus 4 gets cancelled, minus 0 j cap. Otherwise you can write it as plus also. Now minus 4 minus 1 is nothing but minus 5 k cap, because plus into minus is minus. Now let us find out the magnitude of this. So magnitude of A vector cross B vector gives you 10 squared. Again 0 squared, nothing to write because 0 squared is 0, minus 5 whole squared. So 10 squared is nothing but you are getting under the root of 100 plus 25. So therefore you are getting the answer which will be is equal to root 125. So therefore you can write that root 25 as 25 into 5. So let me write it here, half. Root 25 I can write it as under the root of 25 into 5. Otherwise you can take under the root 25 is nothing but 5. So 5 divided by 2, root 5 square units. That's it. And this is how you are going to simplify the given question. Be careful, when they have given the diagonals, you have to take half magnitude of d1 vector cross d2 vector. When they have given adjacent sides, you have to take it only the magnitude of a vector cross b vector. Understood? Now, we'll be moving on to the next type of problem. What they have asked, three vectors a vector, b vector and c vector satisfies the condition a vector plus b vector plus c vector equal to 0. Evaluate the quantity mu is equals to a vector dot b vector plus b vector dot c vector plus c vector dot a vector if magnitude of a vector equal to 3, magnitude of b vector equal to 4, and magnitude of c vector equal to 2. Now, first let us take it as a vector plus b vector plus c vector equals to 0. Isn't it the condition? Then, what is a vector plus b vector plus c vector whole squared? It is also equal to 0. Now, let me take it as a vector plus b vector plus c vector into a vector plus b vector plus c vector, correct, is equals to 0. Now, you can write this one as, what is that? A vector plus b vector plus c vector into a vector plus b vector plus c vector equals to 0. Let us multiply this one. A dot a, which is a vector dot a vector, again a vector dot b vector, again a with c, plus a vector dot c vector, correct, again plus b with abc, so b vector dot a vector plus b vector dot b vector, CDS, b vector dot a vector, b vector dot b vector, again b vector dot c vector plus b vector dot c vector. Similarly, you are doing with c, c, a, c, b, c, c. So, plus you are having c vector into a vector plus c vector into b vector, again c vector dot c vector, correct. Now, a vector dot a vector can be written as what? Magnitude of a vector square. So, here see a vector b vector and b vector a vector is nothing but what? A vector dot b vector is equal to b vector dot a vector, which is a commutative. So, both are same. So, we can write it as 2 times of a vector b vector. Similarly, we can write 2 times of b vector dot c vector, here b vector dot c vector. Similarly, we can write 2 times of c vector dot a vector, c vector dot a vector. Remaining all are magnitude of a squared, magnitude of b squared, magnitude of c squared. I hope you understood that. Now, as it is, I am writing here magnitude of a squared, a vector dot a vector, plus magnitude of b squared, which is b vector dot b vector, plus magnitude of c squared, which is c vector dot c vector. Now, you are taking 2 common factor because all are 2 times. So, 2 times of a vector dot b vector plus b vector dot c vector plus c vector dot a vector equal to 0. Now, what you are going to do? Substituting the values. They have given magnitude of a vector is 3. So, magnitude of a squared, it will be giving you 3 squared. Similarly, magnitude of b vector is 4. B vector square gives you 4 squared. Magnitude of c vector, they have given it as 2. It will become here 2 squared plus 2 times of, you can observe here they have given it as, which will be is equals to mu. So, therefore, I can substitute mu. So, by substituting 2 into mu, okay, equal to 0. Now, you can simplify this. 3 squared is 9 plus 16 plus 4 plus 2 mu is equals to 0. Let us add all this. 16 plus 9 is 25. 25 plus 4 is 29. So, 29 plus 2 mu is equals to 0. Otherwise, 2 mu is equals to, take 29 to that side, it will become minus 29. Otherwise, mu will be is equals to minus 29 divided by 2. That is your answer. They have asked you to validate mu itself. I hope you understood all the steps of this problem. Now, we'll be moving on to the next problem, dears. What they have asked. Three vectors A vector, B vector and C vector are unit vectors satisfies the condition A vector plus B vector plus C vector equals to 0. Then find A vector dot B vector plus B vector dot C vector plus C vector dot A vector. Same type of problem as similar to the last one. Now, instead of mu they have given this. That's it. Now let us take what they have given. A vector plus B vector plus C vector equal to 0. Whole square of this also will be equal to 0. Whole square of this also will be equal to 0. Now writing this, A vector plus B vector plus C vector into A vector plus B vector plus C vector equals to 0. Let us multiply along with the A along with all the terms. So A vector dot A vector plus A vector dot B vector plus A vector dot C vector. Similarly along with B. So B vector dot A vector plus B vector dot B vector plus B vector dot C vector. Similarly along with C plus C vector dot A vector plus C vector dot B vector plus C vector dot C vector. Now, you can write this one as will be is equal to magnitude of A vector squared plus magnitude of B vector squared plus magnitude of C vector squared, because A dot A magnitude of A squared, B dot B magnitude of B squared, C dot C vector magnitude of C vector squared. Now, you can take two common factor because everything is 2 times. So, 2 times of A vector dot B vector plus B vector dot C vector plus C vector dot A vector equal to 0. This what they've asked you to evaluate. Now let us substitute the values of A vector, B vector and C vector. They have given it as unit vectors. Unit vector means magnitude of A, magnitude of B. Since given A vector, B vector, C vector are unit vectors, what is the magnitude of that? It will be equal to 1. Magnitude of A vector is equals to magnitude of B vector is equals to magnitude of C vector, which is equals to the value 1. So let us substitute the value 1, which is 1 squared plus 1 squared plus 1 squared plus 2 times of A vector dot B vector plus B vector dot C vector plus C vector dot A vector equal to 0. Now 1 plus 1 is 3. So 3 plus 2 times of A vector dot B vector plus B vector dot C vector plus C vector dot A vector equal to 0. You can take 3 to that side. So 2 times of A vector dot B vector plus B vector dot C vector plus C vector dot A vector equal to -3. Otherwise, A vector dot B vector plus B vector dot C vector. This is what they have asked you to find out. C vector dot A vector is equals to cross multiply 2, which will be is equals to -3/2. And this is a value of the given. I hope you understood these steps, dears. What is the next problem they've asked, dear students? They've asked, let A vector, B vector and C vector be the 3 vectors such that magnitude of A is equals to 3, magnitude of B vector equal to 4 and magnitude of C vector equals to 5, and each one of them is perpendicular to sum of the other two. Sum of the other two, that means like this, A vector dot sum of other two means remaining are B and C. So dot B plus C, because sum of other two vectors equals to 0. Similarly, other two means if you take B dot A plus C. If you take C dot A plus B, like that. So given condition I am writing. So find magnitude of A plus B plus C vector. So let us take in the given condition by data. You can write like this. By data, A dot sum of the other two vectors dot product equals to 0. Similarly, they have given it as B dot A plus C is equals to 0. Similarly, C dot other two means you are getting A plus B or B plus A is equals to 0. Correct. So this is the given condition. Now let us take whatever they have asked you to evaluate, magnitude of A vector plus B vector plus C vector. I am taking whole square root of this one. If you take whole square root of that, I can simplify by taking A vector plus B vector as like similar to the last one into A vector plus B vector plus C vector. Now listen carefully this one. So first I am writing A dot A. See, A vector dot A vector, and then I am writing plus A vector B plus C, because I need to use this condition whatever they have given. So A dot B plus C, A dot B plus C. So A dot B plus C. I hope you understood this one. Similarly, I am taking B dot B. See, B dot B. With this it is over. Remaining is what? A plus C. So therefore B dot A plus C. So plus B dot A plus C. Okay, similarly I am taking C dot C, that is C dot C, plus you are having C dot, what is remaining? A plus B. A plus B or B plus A. C, right? So therefore now A vector dot A vector gives you what? Magnitude of A squared. So let us write down that. So magnitude of A vector plus B vector plus C vector whole squared is magnitude of A squared plus magnitude of B squared plus magnitude of C squared plus A vector dot B plus C plus B vector dot, you are having A plus C plus C vector dot B plus A. Correct? So what is this? These are all equal to what? 0. Let us substitute, and substituting the value of magnitude of A vector as 3, magnitude of B vector as 4, and magnitude of C vector is nothing but 5. So 3, 4, 5. So writing, which implies 3 squared because whole squared plus you are having 4 squared plus 5 squared. So all this will be equal to 0 plus 0 plus 0. Now let us simplify this. 3 squared is what? Which is 9 plus 4 squared is 16 plus 5 squared is 25. So therefore you are going to get it as, so 25 plus 9, it is nothing but 34. 34 plus 16 is 50. So you are getting 50. But be careful, in the left hand side, magnitude of A vector plus B vector plus C vector whole squared. So therefore magnitude of A vector plus B vector plus C vector is given by under the root of 50. This under the root of 50 can be written as root 25 into 2. 25 2s are 50. Under the root 25 is 5. So 5 root 2 is the value of magnitude of A vector plus B vector plus C vector. Understood? So that's it. The simplification. Is that easier? All the problems what we have solved is easier here because they are going to ask you only for adjacent side. At that time, the area of a parallelogram will be magnitude of A vector cross B vector. If they ask for the diagonals, then the area will be half into magnitude of A vector cross B vector. If they ask the triangle, then half into magnitude of A vector cross B vector. If they ask for the points A, B, C, then half into magnitude of AB vector cross AC vector. AB vector you can write it as OB minus OA. AC vector you can write it as OC minus OA. These are all the points you have to remember, dear students. Don't confuse with the formulas. Okay, I hope you understood this session, how to solve the problems of area of a parallelogram and also how to solve according to the given condition of the magnitude of A dot B plus B dot C plus C dot A. Isn't it? So in the next session, we'll be moving on to the next concept of the chapter vector algebra. Until then, dear students, keep watching. Thank you. Have a nice day.